Hello everyone, today let's take a look at Quantipus number 34, another combinatorics question. This one is slightly tricky. We basically have 30 All-Stars in the NBA, 15 from the East and 15 from the West, and we need to pick a 9-player Olympic roster from these 30. Now, one thing that you may have done that you absolutely cannot do is say, okay, I need to start with at least 3 coming from the East and at least 3 coming from the West. I have 15 total in each, so I'm going to take my 15 and I'm going to choose 3 of them, and I'm going to take my Western players, 15, choose 3. And now that I've done that, I will have 24 remaining, and I just need to choose 3 more to make my team of 9. So we cannot do this right here. Well, why not exactly? Basically, what you're doing here is you're taking your combinations in 3 different steps. So you're essentially assigning 3 different roles, even though there only should be 2. You're saying, let's choose 3 for our Western role. Then you're saying, let's choose 3 for our Eastern role. And then you're saying, let's choose 3 for this other role. But there is no other role. The players that you select here are either going to belong to the Eastern or Western Conference, so you're going to end up overcounting here. For instance, first for the Western, I'll say select KD, Steph, and Clay. And then for the East, let's say I take LeBron, Paul George, and Kevin Garnett. And then for our extra players, let's say I take Dirk, Tim Duncan, and Draymond. Well, these players are all just members of the Western Conference, so when we take another combination, let's say we take Dirk, Tim Duncan, and Draymond first over here, well then we could take these 3 over here, right? And then we're just obviously going to end up overcounting. So sorry to go on that little tangent there. Basically, the moral of the story is that you cannot multiply these choose expressions if these different stages are basically trying to pick from sets that are overlapping like they are here. So how would you actually solve this problem? Well, we know that we need to choose 9 players. 3 of them are from the East and 3 of them are from the West. So because we just have 2 unique subsets, right, the players from the East and the players from the West, we're going to want to end up multiplying 2 choosing expressions, 2 binomials, where one of these chooses the players from the East and then the next chooses the players from the West. Well, I know that I need to have at least 3 Eastern players, so let's just start with 3 Eastern players and let's just say everyone else is a Western player. Well, then in this case, I have 15 Eastern players and I'm choosing 3 of them, and then I have 15 Western players and I'm choosing 6 of them. Now instead, imagine I had the case where I had 4 Eastern players and 4 Western players. Well, now I have 15 Eastern players and I'm choosing 4 of them, and then I have 15 Western players and I'm choosing 5 of them. Now imagine that I have 5 Eastern players and 4 Western players. Well, then I have 15, I'm choosing 5 for the East. I have 15, I'm choosing 4 for the West. And then finally our final case, let's say we have 6 Eastern players and 3 Western players. Well, then I have 15, choose 6 times 15, choose 3. And then these cases are exhaustive because we know that we cannot replace one of these Western ones because we know we have to have at least 3 Western players. Therefore, when we sum all of these 4 terms up, it's going to give us our final answer. I wrote it in summation notation in the problem answer, but this is just it expanded. So now let's just move on to part B here. So now for part B, they ask, in how many ways can you choose your 9 players so that at least 1 comes from the Eastern Conference? So we start with 1 Eastern player, and now we could solve it in the same way as we did before, where we fill in everyone else with Western, and we do the number for that. It's going to be something like this, and then we replace an E, and we do it for this, and we do all the way up to where it's all E's, but this is just going to be a lot of terms. Now, a much simpler way to solve this is just noticing that saying at least 1 Eastern player is just equivalent to saying let's take the total and subtract the case off where everyone is a Western player. So the total number of cases unrestricted is just going to be, well, we have 30 players and we just need to choose a 9-person team, so 30 choose 9. And then let's subtract off the number of cases where everyone is a Western player, so we have 15 Western players and we're choosing 9 of them, and we have 15 Eastern players and we're choosing 0 of them. This is obviously just 1, we can ignore this. So then this is going to end up being our final answer for part B.